So hi guys, welcome back to another video on my channel. So today we're gonna move on to some of the application of the integration. So on the previous chapter, it's all about some techniques and that we use to evaluate the integral. So now we're gonna move ahead and use those techniques and all the things that we know about integration, and we now apply to find the areas and volumes and much more. So now the first topic I want to discuss with you guys will be the area between curve. So let's say if we have y equal to f of x and y equal to g of x, and the line x equal to a, x is equal to b, where f and g, where these two functions are continuous, and f of x is greater or equal to g of x for all x in in the interval from a to b. So the area will equal to the integral from a to b of fx minus g of x dx. So this is the really important formula that you're gonna use uh, in this topics. So, and if the two curve cross each other like this, so I will give example like this, it's cut over here and over here, then the integral need to split up into each region. So I will discuss it more in the example. So now let's jump on to some example. So now find the area of a region enclosed by y equal to x squared and y equal to 4x minus x squared. So now first we gonna graph the function first. So we can know which region we need to find the area and which function will be greater than the other one. So now let's do it. So first one, we will consider the parabola. So y equal to 4x minus x squared, and uh, on the algebra course you will know that the vertex, the lowest point, or the highest point in this case is a lowest point because of the negative x square. So the vertex is 2 4, because this also equal to negative x minus 2 square plus 4, and something square is always greater than or equal to 0, but this is a negative of a square, so it have to be smaller or equal to 0. So overall this will smaller or equal to 0, equal to 0 plus 4, and it's equal to 4. And next we have to find the intersection point. So let these two equation equal to each other. So, and it will give us x equal to 0 and x is equal to 2. So now we can graph the function here. So first we have a parabola. So parabola will look like this. Parabola. The this one is much more easy to graph, so it will look like this. And for this one you will find the location of the vertex first. So this is 0, and the vertex is 2 4, so we will estimate it over here 2 and then 4 over here. So this is the vertex, and the intersection point is 0 and 2, so we can grab it and it will look something like this. Oh no, wait, actually I do something wrong here, so let's grab it again. So 2 will be here, 4 will be here, and it will intersect at 0 and 2. So 2 is here, 0 is here. Okay, intersect at 2, so it will cross as here. Okay, so it will cross at 2 points like here, and the region that enclosed by this parabola will be this one, will be this area. So you know which one is greater, right? The y equal to 4x minus x square will be greater than x square in this region. So we will apply the formula that we have, so it will be equal to the integral from 0 to 2, because this is the limits of the region, so it is 0 and 2, and the greater one will be 4x minus x squared, and minus the smaller one is x squared, and don't forget the d of x, and the rest will be evaluate the integral, the definite integral, so it's kind of easy. So it will equal to 4x minus 2x squared dx, and it will equal to 2x squared minus 2x cubed over 3 from 0 to 2, and it will equal to 2 multiplied by 2 square minus 2 multiplied by 2 cubed over 3 minus 0, and it will equal to 8 over 3. The answer is 8 over 3. So this first example is kind of easy. The only thing you needed to graph these two function on the oxy, and you use the formula that I provide to find the area really easy. You don't have to split anything. So let's moving on to the next one. So this one you have to split the region into two different area and evaluate each of them, and then sum the total, and then take the sum to. So let's moving on to the example number 2. So find the area enclosed by y equal to 1 over x and y equal to x, and y equal to 1/4 over 1/4 x for x is greater than 0. So now let's graph it. So y equals to 1 over x, you guys will see that the graph will look something like this. It will have two curves, one on the first quadrant and the next one will be on the third quadrant. So, and then y equal to x, it's just a line like this, a line through the origin like this, and then 1/4 x is more like I would say it less steeper, so it will look something like this. So this is 1/4 x, and it is a y equal to x. So now the region that enclosed by these three graphs, and you have x is greater than 0, so you don't have to worry about something that There are some x that smaller than 0, so you don't worry this region. You don't need to consider this region. Only consider the right side, and the area will be this one, will be this. So now the first thing you need to find the intersection. You need to find this dot, you need to find this location of these two dots, and so let's do it. So the intersection point, so let's say this is A and this is B and this is C. So A is 0 0 and B is the intersection between line the function of y equal to x and the y equal to 1 over x. So let make this equal to each other, and that will give us 1. So b will be 1 1, and c is the intersection point between 1/4 x and 1 over x. So so let make this one equal to each other, and it will give you x is equal to 2, so c is 2 and 1/2. So now the area will be equal to, so you, as I say, you have to separate this region into two smaller area. So and this will split out right here. So we split out right here. So the left region will be enclosed by the function of y equal to x and the function of 1/4 x, and the region on the right will enclosed by the function of y equal to 1 over x and the function of 1/4 x. So the area will be equal to the integral from 0 to 1, because it's split at 1 right here. This is 2 x minus 1/4 x dx plus integral from 1 to 2 of 1 over x. 1 over x is greater than 1/4 x, so you have this thing, and the rest we just evaluate the integral, really easy. So you have 3/4 x dx plus 1 to 1x minus 1/4 x dx, and this is equal to 3 over 8 x squared from 0 to 1 plus natural log of x minus 1 minus x squared over 8 from 1 to 2, and this will equal to 3 over x plus natural log of 2 minus 1/2 minus natural log of 1 plus 1 over 8. So this one will equal to 0, so and this also equal to 0, so the final answer is natural log of 2. So the key points of this problem is to know where to split the graph. You have to split the graph into two smaller regions. and evaluate each of them, and then sum it up, and you will have the answer. So thank you for watching.